Good morning. I see a lot of names I recognize and a few that I don't. Wonderful to have you all. I guess it's morning for me, but it could be any time of the day for all of you. Right. So maybe before we start officially, it would be wonderful to just test how this Q&A and chat function work. If you would, Megan, I see you online. Would you post something in the chat? I want to see how that works. Thank you, Venkat. Appreciate it. All right. So it looks like I believe everyone can see the chat. So if you put something in the chat, that will let anybody see, so we can have discussion that way. I believe you can also raise your hand when we do Q&A if you would like to speak. Okay.
I think you can start, Laura.
Great. Okay, let me try this sharing my screen here. So I'm Laura Riamaki, and I've been sort of herding the cats on some of this ocean radiometer best practices work. Here we go, put my slide up here. So I just wanted to give a brief introduction about who we are and what we've been working on, so that if there are new folks here, they can kind of walk into the room a little bit more informed. So we have been a community of practice really for the last 4 years. And we started the OBPS workshop in 2020, working on ocean radiometer best practices. And this group has been wonderful. We had several different OBPS sessions over the years, and that led to a paper on broadband radiation, so the energy flux measurement best practices that just came out in Frontiers this year. So that was the culmination of a lot of effort from this group. Thank you all for your contributions there. And then I wanted to give a few other highlights from what we've been working on this year. A shout out to Sean Smith and Katie Watkins Brandt. They are leading a workshop for technicians at the RB Tech meeting. I forget if it's October or early November, but coming up soon. So they're going to be training ship technicians with the best practices that we came up with in the paper, which is, I think, a really wonderful add-on to the work that we've done as a group to kind of come up with how to make the best measurements on different ocean platforms. And then there have been a few presentations this year. The Ocean Sites meeting was a big highlight for me, being able to present our work there and start to get buy-in from different really wonderful networks and great measurement communities. And then also, I wanted to talk a little bit about what we're doing now. So as a group, after we got this paper out, we decided where we really wanted to focus on was kind of those areas that still needed some investigation. So interoperability experiments, comparison experiments, to kind of answer some of the questions that we have about what are the best practices moving forward with new instrumentation, with the new knowledge that we're gaining by sharing with each other our work. So that's really what this community of practice is focused on right now. And we have been meeting every couple of months or so. And this is one of those meetings. And so we welcome new folks. If you'd like to be part of this work, you can send me your email. I'll put it in the chat as well, but I have it right here on the slide. And then I will put you on the email list, and you're welcome to join in any way that fits sort of your work. And then I think that's also going to shape our session today. So we're going to hear from 3 different folks about different pieces of work that they're doing. And this is pretty informal. I hope there's some discussion. So Q&A is welcome. If you'd like to put things in the chat to respond at any time, I'll try to be monitoring that. And then also, if you have a comment you'd like to make, then I think you can raise your hand and we should be able to have you share as well, I think. Anyway, wonderful to have you all. And I won't take up too much more time with this introduction. I'll put my email in the chat. So anybody who is interested in being part of that email list, if you're not on it, then please send me your email. And with that, I will turn over the slides to Bob.
Okay, thanks, Laura. Okay, so I'll try sharing. Okay. Everybody see those okay?
Yes, looks good, Bob.
Okay, so I'm a big proponent of intercomparisons and intercalibration. So let me go into that a bit. The group that I work with, Al Pluteman and Tom Farrar, we do sustained surface mooring observations of surface meteorology and air sea fluxes. So here's an example of our buoy north of Oahu. A little bit of background, how accurate do we want to be as oceanographers? And a lot of the background for oceanographers to do surface radiation is to get the surface heat flux. And a lot of people suggested in the 1980s and 90s, we need to get the net heat flux to about 10 watts per square meter. Early on, when I started to do this type of work, I was looking at the accuracies from experiments we were doing in the 80s to the present about how good surface buoys, surface fluxes were. And that's just a summary. It was really bad initially, and we've gotten a lot better. But initially, we didn't even measure long wave. We often used parameterizations involving cloud cover, SST, and air temperature, and cloud fraction from shortwave. But we had large errors in radiometers, and we know we needed to do better. This was driven home, and some of the background for why comparisons are really important is one of the early things people tried to do in the Toga Core in the Western Pacific was interlace ships, buoys, and airplanes and come up with a common consensus and agreement on what the surface heat budget of the ocean in the Pacific warm pool was. So there were these nested arrays, all those people worked together, and here's a result. So in the left, you see shortwave radiation measurements from different platforms. On the right, you see incoming long wave. And the top two panels are, this is what we got after the experiment. We threw it in the same bin and we did common plotting. And boy, were the incoming long wave measurements very different. So there was a very extensive intercomparison, intercalibration experiment, which led to improvement. So you see in the lower right, the incoming long wave measurements from ships and buoys are now much better. And there is not a weird effect. The shortwave, the daily shortwave is plotted in the background. There's not some weird effects of the solar heating in the midday. So Toga Core set some basic, Laura, this was where we sort of started to make best practices. And a lot of it is captured in the paper that you led. So I'll just move on. We kept going with surface buoy observations in some rough environments like off Eastern Canada, Arabian Sea. Presently, we do buoys that last for about 12 months at a time. We have two sets of redundant instrumentation and sometimes a third set of independent. And you can see a cluster of two shortwave radiometers and two longwave radiometers. Some of our sites have now more than 20 years of data sampled at once per minute. Our approach has been to we developed our own surface meteorological package, doing some best practices of placing amplifiers and signal conditioning very near the sensors, recording all the basic measurements, such as thermopile voltage and thermistor readings in the radiometers. So we're campaigning incoming long wave and incoming shortwave sensors that look like this. Again, some of the best practices we try to follow are in the right with the signal conditioning, stable amplifiers of the thermopile voltages, provision of engineering units, fast sampling and making boxcar averaging. And we try to calibrate the whole unit, not just the sensor head. So this is the sort of accuracies we've published. I'm not going to dwell on them, but we think we're meeting that initial goal for oceanographers of better than 10 watts per square meter in the net heat flux. What's the data get used for? It gets sent off to modelers and we do comparisons of models. Here's a model comparison with our three long-term buoys against reanalyses, and just to hover over the long wave, the point here is that the buoy measurements differ in annual averages from the long wave by up to about 15 watts per square meter. If you do a cluster of annual means of net long wave and net short wave, the models perform really differently in some cases from the buoys. If you look at the histogram of something like net short wave, it's different in the buoys and the models. So we think the buoy data right now is good enough to challenge the modelers. Jim Patemra at the University of Hawaii has compared buoy observations from our buoys with the NCEP CFS model. And he says, well, the model doesn't get the diurnal cycle of the radiation correct compared to the buoy. We also export data and share it, and people like Rachel Pinker and the people at Ceres have compared it against the satellites. But all this sharing of data makes us want to work with you all to really understand the uncertainties in the unattended buoy measurements. Over the years, we worried about buoy motion. We actually measured motion. In the upper left, we made a 2-axis gadget that tilted it, pitched and rolled our radiometers on our roof. We've sailed out with Chris Farrell's group and stable platforms. We don't think tilt's a big deal. Our buoys have a very high loading on the bridles beneath them, and they're pretty stable. We worry more about mean tilts. This is our calibration on the roof running against other radiometers, and you can see new KIP and zonans being tested as long as ventilated ones. We did have a good participation with BSRN in the old days with the Chesapeake Bay Light Tower. We're moving to a lamp-based calibration for shortwave, but to give you a good example of why we should do calibrations is for many years we sailed with Chris Farrell, now Elizabeth Thompson's group, and we would use Chris Farrell's group as a sort of standard. So we were both campaigning EPLI PSPs, and we would send our PSPs to Chris for comparison on the roof of their building in Boulder. And well, it turned out that we were both comparing against EPLI PSPs that were slowly aging. So when Chris's intercomparison facility rotated in some brand new PSPs, we no longer had a good agreement. And you can see the problem in the upper left to the left, one of our units that's been out at sea a lot, you can see that the optical black paint is now sort of ash gray. And this is, and compared to a new one freshly coated at EPLI, we tried to research this, and if we hadn't done the comparison with Chris Farrell, we don't think we would have found it because it's only in the very gray literature in the lower right that we see that this aging of the paint has been documented. So we're really keen on comparisons just to get on the same page as everybody. How do we calibrate per geometers? Well, we have a temperature bath, a stable temperature bath with good standards. We made a copper body and we painted the inside of the copper body with Parsons black. The per geometer module nests inside and looks downward at this stable temperature bath, and that's how we check the calibration on the per geometer. And we do a lot with long-term deployments. I think Danielle's going to talk about intercomparisons too. We do that at sea. We overlap buoy deployments. We try to compare the short wave and the long wave between the old deployment, the overlap new deployment, and the buoy deployment. But if you look at intercomparison plots of incoming long wave on the right, where both the research vessel and the two buoys are plotted, I don't know how to make a lot of sense out of that. There's a lot of scatter in those measurements. We keep doing it, these intercomparisons. When we burn buoys in before deployment, we compare the 2 or 3 per geometers on it. If it's questionable, we replace it. When the buoy goes over the side and we compare to the ship, if the per geometer is questionable or any instruments, the guys get in a small boat and they replace the sensor. When we come back, we compare the several redundant measurements on the buoy and we compare statistics. So let's look at what gives us gray hairs about per geometers. In the upper left, what I've done is I've taken the daily incoming long wave radiation from a buoy north of Oahu. I've plotted it, and then I just did a MATLAB fit and to get the red line. And that's pretty worrisome to me that the red line of the mean of the incoming long wave looks like that. In the right, I took some of that same data and I just did a scatter plot of 1 minute incoming shortwave against incoming long wave. And the color is the age of the data. And what worries me about that is look at the blue fringes on the low end of long wave and on the high end of long wave. And that's the earliest years of that deployment. What that says to me is those two plots say to me the mean of the incoming long wave in the initial years of the deployment and the daily range, maybe, or the range associated with switching from cloud free to cloud cover is wrong. And backtracking this is what we found was in years 1 through 3 of this buoy deployment, the amplifiers we were using to amplify the thermopile voltage were not stable in the sense that when our tech did that calibration in the water bath and set the constants and coefficients and then turned the module off, when that module was turned back on, the gain and the offset in those amplifiers jumped. So we fixed that after year 3, but that's the sort of concern we have is the thermopile voltages and the per geometers is so small that worrying about the stability of the amplifier is a big deal. Another thing about that per geometer data is taking 9 years of data off Chile in the left and doing the power spectrum is why do I have spectral peaks in incoming long wave at the 24-hour period, the diurnal period, and maybe a harmonic at 12 hours. So shifting over to the right and taking 2 different years of 1-hour resolution incoming long wave and looking at the seasonal histograms and where the gray bar is the local solar noon. What the heck in 2009, why do I have peaks in incoming long wave in spring and summer of 2009, close to local solar noon? And I don't really have them, or they're not as clear in the year 2020. So it starts to make me wonder whether there's something wrong or something funky about some of our radiometers. And we'll return to that, but just to be upfront, another thing that drives us crazy on these unattended observations are seabirds, and they tend to land and want to sit on the radiometers. We tried some sort of mild-mannered stainless steel spikes in the left. They're not good enough. The birds just go and break them and sit on them anyway. And we're going to more aggressive spikes on the right. But we need to qualify the uncertainty due to those spikes. So just wrapping up, and I won't read it all, but I'll focus on the long wave. Things that are worrying us is we don't really understand our long wave sensors in the sense that why do we get the 24-hour response? Do we have peaks that are letting incoming shortwave through? Do we have sensitivity to case heating? What are the problems? As a backdrop for this, we're going to have, with EPLI out of business, we're going to have to shift from a large collection of EPLI PIRs to Kip and Zonin. We want to try to do comparisons with other people and somehow qualify the Kip and Zonin sensors as good as the PIRs or similar to go forward with continuity in the observations. So in the end, I'm really looking forward, Laura, if we can get together and do some intercomparison experiments, compare our buoy per geometers against better quality and other people's per geometers, understand them better, learn how to calibrate them better, and to learn more about whether we're having errors associated with solar heating or shortwave leaks. That's it, Laura.
Thanks, Bob. That's a great talk. So let's open the floor to questions. I think you can put your question in the chat, or you can raise your hand, and I think Katerina can give you permission to speak. So Bob, let me just start with a clarification question. That those results that you're seeing with the per geometer data, that the diurnal cycle effects, is that with PIRs? These are EPLI instruments?
They're all
Or
EPLIs right now. We're just in the process of testing and converting to the KIP and Zonans, and we just have to make new interface boards. And we're also trying to figure out whether we want, I think also the industry's at the point where they're transitioning to digital instruments. So do we jump to a digital instrument and not worry about the amplifiers and trust their amplifiers? A lot of questions for us.
maybe I'll just ask another follow-up question on that 24-hour signal. So it went by quickly enough that I'm not sure I followed, but if you're seeing a 24-hour frequency, could that be real? I mean, like you would have a diurnal cycle in the temperature of the atmosphere.
Yeah, that's a good question because say off Chile, where there's a marine stratus deck, and there's also an atmospheric wave that propagates westward from the Andes. There is a real signal that flips between low stratus cover to clear sky, and it has at times a diurnal variability. So yeah, so that's what confuses us, is it's potentially real and associated with cloud cover coming and going, or it's potentially case heating because we don't have the power, we don't run up ventilators, or it's some of our PIRs have got some wear and defects in their coatings. That's why another motivation for us to get the long wave calibrator going for shortwave sensors is to also run our long wave sensors under the halogen lamp to see whether they respond.
Oh, that makes sense. Looks like we have a question here in the chat from Marcel. What should we consider as the largest issues facing radiation measurements from uncrewed mobile platforms such as wave gliders? Do you have any advice for Marcel, Bob?
From wave gliders, so you're low down near the surface. We initially, years ago, we convinced ourselves by recovering shortwave and long wave as deployed on the buoys and then checking the calibrations to see if a sea salt coating impacted them. I think I worry more about water droplets, the hygroscopic salts causing water on the film of a PIR sensor. I mean, since you guys are better at this than I am, I would assume that the water droplets are so opaque to infrared that they're going to really impact. So I would worry about spray and water, and maybe we also encounter some lipid and some biological films from algae that get on our sensors and don't wash off. So those concern me.
Yeah. And I would say for the shortwave on the wave gliders, I think the tilt is something to really think about if you have sort of persistent tilts from these mobile platforms. The buoys, I mean, you've convinced me pretty well, Bob, that the buoys tend to average out over time, but a wave glider may not do that.
Right, but I mean, Megan's group and some of the folks are on have been heavily invested in that, and I think they're campaigning what's the other sensor that does direct, diffuse, and direct?
SPN1, yeah.
Yeah, and another reason for that, I think, we had this discussion with Christian earlier this year about why our buoys see incoming shortwave peaks way above the solar constant, and it's due to reflected light, I thought, but I think it's partly because not only is the direct, but the diffuse is cranked up by the cloud cover, and an SPN1 might help you understand that.
Yeah, it's one of the recommendations in the paper, Marcel, is also to think about measuring diffuse. I've got a question from Dave Rutan here. We can do a spectral analysis of the long wave record at the Chesapeake Lighthouse and see if they find a similar noon peak. And I think they switched at some point from Eppley's to Kippenzonen.
Oh, that would be great.
Tom Farrar. There's a good conversation going on in the chat here. Let me read it real quick to see. Tom Farrar mentions that they've measured mean tilts on wave gliders and buoys, and wave gliders have very small mean tilts. Nathan Anderson says, I'm interested in any comments you have on the long wave radiometer spikes seen in a few of your intercomparisons earlier in your talk. We have seen similar upward spikes occasionally with Kippenzonens on sail drone and also on buoys with Epleys.
Yeah, I agree. I agree completely with Nathan. I sort of zoomed by it, but when we compare the buoy to ship and the redundant incoming long wave on the buoy, we do see upward spikes. And I got to say, I don't completely understand them. And one of my homework items is we've started running ventilated Kippenzonens on our roof platform. And I was going to go back and compare the roof PIRs unventilated to the ventilated Kippenzonen infrareds and see whether the PIRs have more spikes. I mean, we've seen transients in the PIRs for years, and I can't say that I understand them completely.
Nathan followed up. Looking at buoy data, the positive spikes have almost never occurred in tandem, so I typically flag these on redundant systems. Interesting.
Well, it'd be fun to do an experiment of going out, Nathan, on the roof and misting one of them, or taking an eyedropper and putting some water on one of them. But we've also been worried about thermal gradients and things within the case. So
Yeah, that's interesting. What time resolution are you seeing these spikes in, Bob?
that's in our raw 1 minute data.
Tom also mentions that they get positive long wave spikes from birds on their buoys.
Yeah, for a while we had a bird butt algorithm. Was a bird roosting on the PIR, and the birds and their guano, it's a real problem, which is why we've gone to those aggressive metal spikes. So I'm real curious about what other people do to deal with the birds, because I mean, once a buoy sits there and gets a local ecology ecosystem, you draw birds and they want to sit on something.
Yeah, Daniela's confirming there that she also sees spikes from birds and bird guano. Yeah. Other questions for Bob or comments? Go ahead, Daniela. I think you're muted.
Yes, I would like to add that we have been comparing apply and Kippenzonen pure geometers on our land observatory, but we have not noticed any particular spikes in the apply model.
But you have seen them in the Kippenzonen? Or
No. I guess maybe spikes are not, at least in my experience, are not due to instrumental failures, something like this.
a good piece of evidence in the mystery. Right. Daniela, let's move to your talk. If you're ready.
Yes. Okay, I'll share my screen. Okay, can you see my presentation?
Yes, it looks good.
Okay. Good morning or good afternoon. I will present the shortwave and longwave irradiance measurements at the Lampedusa Oceanographic Observatory and highlighting some strengths in having close land and ocean sites, and also some disturbances that I found on marine irradiance data. Lampedusa is a small island in the central Mediterranean, south of Italy, but really closer to Tunisia. It is small and flat, and that makes the measurements on the island representative of a larger area. The island hosts an integrated observatory, which is composed of 3 observing points: the atmospheric observatory, the eldest one, established in 1997, the Oceanographic Observatory in southwest of the island at about 15 kilometers from the Atmospheric Observatory, and the newly established Terrestrial Ecosystem Observatory. And we have radiation measurements in all of the 3 sites. The Atmospheric Observatory is close to the lighthouse. The main building hosts different instruments, including radiation measurements, those for radiation measurements that started in 1997 with the Brewer spectrophotometer, while broadband radiation measurements begin in 2004. The site belongs to international networks and European infrastructures. And here are the reference instruments on the roof of the main building. The site entered the BSRN network last July, and the instruments are regularly calibrated and maintained. And here we carried out our instrumental tests. The Oceanographic Observatory is an elastic beacon that was designed to minimize rotation and oscillations for the validation of satellite observations and studies on Earth's interaction. The sea bottom is at about 74 meters. We have instruments in the water and outside the water. For example, a VIII weather station for pressure, temperature, humidity, and wind measurements, spectral downward solar radiance, and broadband solar, infrared, and photosynthetically active radiation measurements. So the picture shows from the left the Kippenzonen pyrgeometer, the spectral radiometer, and the part sensor. Measurements on the buoy started in 2016. Data are collected on a Campbell data logger at 1 Hz rate, together with the electronic levels signals. So the advantages of having close land and ocean radiation measurements are manifold. First of all, we intercalibrate radiometers, in particular those that are deployed on the buoy are installed on the roof of the building before and after installation. So we can assess the quality of radiation measurements by comparing land and ocean data, and I will provide some example. We have additional measurements at the Atmospheric Observatory, like those of precipitation, cloud, and aerosol properties that can help understanding the differences and also to carry out different studies. And finally, we carry out instrumental tests, for example, the effect of ventilation, sensors, attitude, and others. So the first year of measurements was published in 2019. Here you can see the plot of daily averages, long wave and short wave irradiance. The shaded area correspond to a period that when the radiometers were not horizontal, so it is not included in the analysis. And the scatter plot of the ocean and land data showed a negative bias for the shortwave and a positive bias for the long-wave irradiance, which was explained with the help of radiative transfer simulations, taking into account the different height of the radiometers, which is 8 meters above sea level on the buoy and 15 meters on land, and also the different surface albedo and emissivity between the two sides. And we found that the differences, the observed differences are well explained by the different installation. So basically, I did a similar analysis for the other years. Here is an example for 2023. I made a scatter plot and see comparable results to those of 2016. But in this case, I'm interested in these points that are far from the fit line. An example is this period between the end of May and beginning of June, when we have first days of agreement between land and buoy shortwave measurements, and then days with very lower values on the buoy. And then after a heavy rain event, we have again that differences become small. So it is difficult to explain if these large differences are due to dirty domes or to other disturbances. Looking at the shortwave irradiance, I don't come to a final solution, because I see how these are hourly means. I see some agreement and then some large spikes, very large spikes when the shortwave irradiance are in agreement, so it's not clear. Similarly, for end of August and September, again, we have days with large differences in the shortwave, but not as large as in June. And in the long wave, again, I see these very large and in some cases persistent spikes, which differences that cannot be ascribed to cloud effect. But by the end of June, we installed a webcam on the buoy looking at the radiometers. So what we found is that birds like staying on the radiometers, in this case on the pure geometer. And looking at the different images, we saw that they very frequently stay on the instruments, not only seagulls, doing things like eating in this case, and sometimes they are very a lot. So what to do? We are trying to test some solutions. In this case, we tested some nylon wires above the domes on the radiometers in the atmospheric observatory, and looking at the differences in shortwave and longwave irradiance with the reference instruments. So for example, in cloud-free days, we see a signal in the shortwave irradiance that is visible in the right plot, where we plot the shortwave ratio as a function of the solar zenith angle. But we don't appreciate the wire effect in the cloudy days, nor in long wave irradiance. The green arrow correspond to the time when we see the largest shortwave effect. But however, in this graph, we can appreciate the impact of the solar radiation on the long-wave irradiance measurements, because here we have the difference in long-wave irradiance between the unshaded and the shaded pyrgeometer, and we see that the maximum difference in this period is up to 6-7 watts per meter square. And these values, these issues was already addressed in a previous paper, and we see that this effect changes with season and may change with latitude, and it should be taken into account when estimating the uncertainty on a long-wave irradiance measurements on the buoy where we don't have, where the radiometer is unshaded. Finally, I used to correct measurements for the thermal offset of the pyrgeometer. So I plot here the nighttime measurements of the unventilated CMP21 on the buoy, and I see that in correspondence of the rain events that are detected thanks to the precipitation measurements on the atmospheric observatory, I see that the shortwave signal from negative becomes positive, and then again in rain events it becomes more negative than in the other days. So when estimating or correcting the nighttime offset, we should be able to eliminate such data that could cause a bias in the offset. If we look at the same measurements for the ventilated reference CMP21, we see that the nighttime offset is much lower thanks to ventilation, although we see a small signal of the rain even in this case. So to conclude, the comparative analysis of the radiation measurements at the buoy and at land allows to evaluate and explain the differences that are mainly due to different installations, but differences may increase due to dirt or disturbances and become small after rain events. We can assess the quality of marine measurements, for example, thanks to the estimation of the pyranometer nighttime offset, excluding rainy cases, and estimating the solar effect on the unshaded pyrgeometer measurements. And finally, the land side allows to carry out instrumental tests and also to simulate what may happen to the radiometers on the buoy. So thank you very much for your attention.
Thank you, Daniela. That was a great talk. Questions for Daniela? I'll get us started. Yeah, the bird pictures were great, Daniela. I was actually very interested to see how much that really thin line affected the shortwave clear sky measurements. That surprised me that it was actually as much as it was. So was it something like 10 watts? Or
sorry, what are you
when you put those thin lines to above the shortwave instruments and you showed those figures?
Oh, yes, they are 0.3. The difference in shortwave irradiance, it was 5%. That corresponds to yeah, maybe more than 10.
More than 10 watts? Yeah, it sounds like coming up with good bird deterrence will be an engineering challenge. Bob
yes,
showed us.
And yes. We also would like to try some other solutions. as that suggested by Brian Fabry from NASA Lark. He suggested he used inverted screws on his instruments in Granite Island. So I would like to test this device as soon as I can I have time to do that.
Yeah. Yeah, the cameras were really helpful.
Yeah.
Looks like Bob has a question here. Bob, you want to say your question?
Yeah, I was just curious, Danielle, what do you think the impact of the rain? Is it because rain falls and it's cool, or because rain gets on the dome?
Oh, I think it may be a thermal effect of the difference in temperature between the raindrops and the dome, but this explains only part of the difference.
Okay.
Um, I really don't know. But I see it every time we have rain on the radiometers.
So
And
Chris Farrell,
obviously I can appreciate this, sorry, Laura, only during nighttime, because during daytime the change is so small.
Chris Farrell asks, does the difference in shaded versus unshaded IR flux scale with solar flux?
Yes, yes, in my experience, yes, because I made such a comparison between ventilated and unventilated instruments during more than one season, and I see that this effect scale with solar irradiance. So it is lower in winter and larger in summer.
Bernard asks, has anyone tried some of the measures taken at airports to keep the birds away, particularly bioacoustic devices and/or sound cannons or reflectors?
We are going to buy also acoustic devices, and we are going to try, because otherwise measurements on the buoy are very much affected.
And Tom asks, is the nylon wire causing a signal by blocking radiation or by blocking birds?
Yes, the wire blocks mainly the direct component of the solar radiation. So we have to evaluate if it is better to eliminate, to cancel part of the daily measurements due to the effect of the wires, or to have measurements affected by the birds. But maybe using the inverted screws that are placed on the white head around the sensor may not affect measurements as much as the nylon wire above the domes. So we have to test this. Yes, the wire is the nylon wire is transparent.
Yeah, very interesting. I guess I want to ask Bob, after seeing Daniela's results, if he thinks his long wave spikes could be due to birds.
Well, that's certainly possible. We did try for years nylon fishing line, crisscrossed across, and at least particularly off Hawaii, the birds just crash into the buoy and they break the fishing line. They also break the anemometers. They seem to take a terrible toll on our propeller vane anemometers, and for some reason they may be pecking the acoustic sensors on the acoustic anemometers too. So the birds are a problem, but you can see we went to very, I mean, I don't know what they are. Tom might know, but it's sort of almost 1/4 inch diameter sharpened steel, stainless steel spikes now is what we're going to use, which I showed in that slide. And yes, I mean, like Danielle, we have to do intercomparisons. So we'll field a trial bird spike set on the buoys and compare it to an unbirded spike set. But birds are a problem.
Yeah.
It's been a great discussion. Any other questions for Daniela?
Laura, I guess I'm interested in Daniela. In your incoming shortwave measurements, I didn't see that you ever spiked higher than the solar constant. And I guess I was surprised with the Hawaii buoy, where I think we saw a max one day of 1470 watts per square meter of incoming shortwave. But the BSRN site on Mauna Loa, with Christian's help, we found had the same thing. And it's this additional amount of incoming shortwave associated with bright white clouds being there. But is it not, do you not get convective clouds in the Mediterranean?
Where we are in Lampedusa, we don't have development of convective clouds because the island is very small, and so we only see synoptic scale phenomena, and so, as I said, the island is too small to be how to say,
it's not an orographic impact.
yes.
Yeah. Okay.
Awesome. Well, James, are you ready for your talk here? Let's move to James's talk and then we can come back to group discussion.
Okay, guys, I'm hoping this is going to work out. I'm having to use my phone as a hotspot. So far, I've seen your presentations, everything, but our internet here is up and down, up and down, up and down. We're having major problems, so wish me luck. All right. Well, good morning, can everybody see it now?
Yes, it looks good.
Okay, good. So I am the engineer of the group, so you'll forgive me if my science is not nearly as strong as yours is, but I am the technology development lead here at NDBC, and I'm also the TAO recap project manager as well. And I just wanted to give you guys a little bit of an update. I'm actually going to, talk about rain as well, just because we're expanding our network to include those measurements across the network. So I just wanted to give you a little bit of status on where we are. It's going to be a very common theme. So let's get into it. So as we all know, EPLI is what we've been using for the pyrgeometer and the pyranometer. But as we all know, they're going away. And we have actually settled on the Kippen-Zonen pyranometer and pyrgeometer. We just finished 1 year side by side on 2 separate stations. So we actually had a refresh and a recap side by side at 0180 and 0165. We did a report for the 180 days. I do not believe we've completed our year because those buoys were just picked up. But the 180 day, we were kind of in a crunch of, we have to spend our budget before the budget expired. So we had to make a decision at 180 days that the Kippen-Zonens were acceptable replacements. So we did purchase enough to populate our entire array. So that's the first part of that. Rain sensor, it's the same rain sensor we've used in legacy. We will continue to use for tau recap. It's the RM Young rain gauge. So just a couple of items of interest. So on our legacy systems, we would sample 2-minute averages for radiation, so 30 of them, and we would report those 30 hourly. Well, with recap, we're actually going to take the same measurements, but we're just we're going to take 5 2-minute averages, but we're going to report them every 10 minutes. So they're actually going to, the reporting is actually going to be a lot sooner. For the science community, I don't know if that helps you, but we are trying to keep that as our new standard of data delivery that matches our scoop systems. That is our new delivery methodology. And for the rain, it's the same thing. We were taking 1-minute averages, 60 of them, and reporting them hourly. And now for tau recap, we'll take 10. Boy, I typed 10 twice. Okay. Anyway, 10 1-minute averages, and then those will be reported every 10 minutes. So where are we on getting these out? So I put October 2023 down there because our legacy system, as it was, we had the 4 flux stations, and so that was it. That's the only places that had radiation and rain at the end of October 2023. Now at the end of this month, we now have those same 4 legacy refreshes out, but we now have 5 tau recaps out. So we have a total of 9 systems that have radiation and rain. Our plan for next year is that we're not going to be servicing one of our legacy buoys on 0140 next year, so that one will remain out as a 01 as a legacy buoy. It got serviced this year, so it still has the EPLEs on it, but we'll have 20 recap buoys. By the end of October 26, we should have 35 tau recaps out and no legacies remaining. And then by 2027, our entire array of 48 buoys should have the Kippenzonen radiation and the rain sensors on board. And that was my update. Now we'll open it up to questions.
Thank you, James. That's pretty exciting news. And sounds like a lot of work for you folks. Maybe I'll start with something general. Is there anything that would be helpful to you from this community as you're kind of making these changes? Like, are there ways that we can support you in giving you information about the instruments or the data and how it changes?
Absolutely. I was actually thinking maybe a good idea to share with you guys the data from those side by sides. You guys might be interested in seeing that data from the EPLEs and the Kippenzonens, because I know you guys are looking into doing that kind of comparison. So it may be good to get that data for you guys, because some of it was, it was on an operational station for the EPLEs was being released, but the test data is here. So we probably, and I was just thinking, I made a note for myself that we need to get that together so I can share it with you guys, and then you guys would have it. I mean, and I can certainly share the reports with you, but you may want to do your own analysis as well. The other thing I found interesting, as a theme here is birds. I have never heard anybody say that we have problems like that. But I'm going to go ask my lab as soon as I get out of this meeting and go, I mean, how biofouled are these things? I mean, how fouled up are these things, when you get them back? Because I really don't know. So that was information. We certainly, as engineers, can build a better mousetrap or bird trap or whatever we want to call it, to try to keep them off of there. But I do know that we have a problem with the rain sensors. We actually have spikes on the rain sensors, but I've never heard anybody say anything about the radiation sensors. But it makes absolute sense.
Yeah, Bob, do you want to say your comment out loud?
Oh, hi, James. I bet you have birds. I mean, I always hear
Hello.
about when we used to sail on the Ron Brown. I always heard about how great the fishing was at the tau buoys. So if there's fish there, then if there's big fish there that Ron Brown wants, then there's little fish, and then there's birds. So I don't know. I think they're a problem for us. And
Oh yeah.
I think on the plus side, since you're close to the equator, I guess I'd be hoping you got enough frequent rain to keep the guano down a bit.
Yeah. I tell an interesting story with our scoop buoy. The way our scoop buoy works is our battery is smart, and it knows when it's not getting charging, and so it starts turning off functionality so that we don't burn the batteries up. And there was one in Hawaii. You were talking about Hawaii. One of our Hawaii buoys was so covered that the solar panels couldn't get any charge, so the battery was going through its modes and it was turning things off. And we're like, okay, it's behaving exactly the way it's supposed to. And then big rainstorm came, washed it all off, and it started coming back up. So it worked exactly like it was supposed to, but it was definitely a problem.
So that was the solar panels were covered with guano.
Yes.
Yeah,
Yes,
okay.
absolutely.
Second
And then
question,
the rain
James.
came and it washed them off, and then
Yeah.
it started charging again.
Did you test the algorithms you chose for when you turn the radiometers on and how you sample them? I mean, did you do some experiments? I mean, like on land, did you compare something sampled continuously or at 1 minute and then do the subsampling to see what the impact on like the daily means or the hourly values is?
We didn't do any experiments like that. We actually are sampling them the same way we did the Epleys. I mean, those are, I mean, these are RS-485, well, Modbus serial output, and so we're just taking, we're taking the same number of samples that we were previously with the Epleys. We were trying to compare apples to apples at the time.
Yeah, there's a couple of comments in the chat there, James. So Tom says that bird contamination will be hard to see in average data, in the longer term averages. And Christian asks, is there still room to consider storing data at 1 minute full resolution? That would allow cloud detection algorithms developed over land networks to be more reliable.
Yeah. So right now we're actually not storing the individual samples. I do believe I'm not going to speak and answer this question, but the capability is probably in the software. We just don't have it implemented. And the reason at the time in our previous, I'm going to back up a little bit. So the device we use for our scoop system is a smart module, and what we went to with this tile recap is a smart module plus. Well, the smart module, we stopped writing to the SD card all the time to store all that high resolution data, is because it was burning up the SD card, and it was causing. However, the SD card was also what was being used to store our transmitted messages before they got transmitted, and if the SD card failed, well, the whole system went down. It was a flaw. The new system, we don't do that. We don't use the SD card for that reason. So we may want to consider, that's a good question, and we may want to consider going back to being able to write to the SD card, and since wouldn't be a single point of failure for the whole system if we wanted to do that, because we're just using it to store a backup of the data.
Yeah, I think it would be worth considering if it's a possibility. I know you guys have engineering challenges that are pretty significant when you're putting these out in the ocean, and I don't know, you're looking at them every year or two. Is that how often you get to do maintenance? Or
we service most of them. Yeah, we service most of the buoys. Some of the buoys we service every year, and then there's a couple of lines that we flip-flop. So it's somewhere between a year and 18 months. It's just that we service them.
We've got some question from Raja, and he wants to know how the TPOS radiometer data are validated during cyclones. And I think he wants to know of this follow-up here, in case any upcoming storm, whether the radiometer has to be separated to preserve the data. I don't know if that.
So I can't speak to the QA/QC. We need to talk to our mission control folks and our scientists, but we do have lots of algorithms that are applied to that data as it's coming in. But I can't speak to what those are right now. I leave that to the experts. I provide the data, and then they tell me what I did wrong, but or what is wrong. But I do know. But that's a good point. It's a good question. If we're not doing something like that, we would be happy to entertain any advice that you guys could give us for improving our QA/QC algorithms.
Yeah, Raja, I don't, do you work with the Indian buoys as well? Do you have the same, I guess I'm asking, are you asking these questions from experience? Are you also dealing with the same question in the Indian Ocean? Feel free to respond if you want to. And then Chris Farrell also said that he predicted that the Kippen zone and IR flux data will need a correction for solar contamination. If Chris speaks, I listen. So I would be curious what your intuition is there, Chris, why you're thinking that will likely be the case. And we have a bit of a response from Raja. Raja, would you be willing to speak verbally so we can interact with you a little bit easier? Katerina, I don't know if you need to give him permission to speak, but
Yeah, I can give. Yeah, I'm trying to. I don't know if they want to. That's.
it looks like you're muted, Raja. But if you unmute, maybe we can talk about your question a little bit more.
Hello, can you hear me? Hello.
Yes, we can. Thank you.
Actually, just for curiosity, I'm asking because in Indian Ocean there are a lot of cyclones. Actually, the buoys, the Omni buoys, and the other buoys, they face these types of hazards. Actually, sometimes actually the intermeteorological department or the other agencies actually they through the viewers ships and other outlets they issue warnings and and before the one and due to this the National Information NIOT Dr. Venkatesan used to work in that agency. This agency and the INCOIs actually our agencies, they are the charge of maintaining the buoys. They do the necessary actually handling the buoys. Sometimes they shift the instruments or they shift the buoys because once if the cyclone, devastating cyclone pass through the buoys, and the instruments are damaged actually, the data would not be actually preserved. So earlier, the whole data may be collected so that if the instrument gets damaged, no problem. And so that's why from curiosity, I'm asking actually, because actually once if the buoy survives the cyclone or any other storms actually, then it's okay. But these instruments are sensitive instruments, so that we have to take care for. Necessary action. So we have to preserve the data from the buoy so that any damage is done to the buoy, so you may not lose the data. That is why just I sought for the information. Thanks.
Yeah, that makes sense, Raja. That sounds like quite a challenge.
So this is one of the challenges I think every buoy agency faces actually in the oceans which face regular storms, hurricanes, cyclones, and all this. Thank you.
Yeah. Do you have any similar policies, James? Do you guys collect data before storms or in case of damage?
No, I don't have this.
So I don't know exactly what I know that when there are storms, that we definitely, and we know they're coming near our buoys, we keep an even closer eye on the buoys, right? I mean, and we look before and after, yes, and we look for any drastic change if we see anything that looks, that's why we have a 24-hour operation here where people are always looking at all the data, right? There's somebody, and then we have automated QC, but we also have manual. If something gets flagged, then they go double check it, and then they also check to see if they see anything that maybe the automatic check didn't didn't find. So this is a constant ongoing process. But yes, they probably do actually pay a lot more attention, especially after a storm passes. Is anything not working properly? What have we lost? We also have the problem with vandalism. It's a similar situation, right, where something gets vandalized. And in the case of radiation sensors, guess what they look like? A camera, and sometimes they'll throw a bag over them, and now you really, don't have anything. So we have to pay attention to that. If especially temperature, I mean, we can tell when a vandalism event occurs because they'll bag it, and it'll all of a sudden the temperature will jump up because it's bagged. And so the same thing for the radiation sensors. You can't trust them at that point, obviously. One other thing while I'm speaking. We are actually, because we're new sensors, we're trying to change our testing methodology here, as far as how we test them here before they go out. We obviously will get them calibrated at Odd Hydromet or whoever does that now, on a regular basis as well, but we test them here before they go out, and we have a couple of standards that we'll test them against. But we've been doing a lot of that manually. We've been doing a lot of that, like, hope it's a sunny day, that kind of thing, which isn't the greatest, way to test. So we're actually in the process right now trying to do some automation, getting the proper lighting, light sources. So any advice that can be passed along to me, any lessons learned on how you guys do those kinds of things would be greatly appreciated, because we are just now in the early stages of doing that.
Great, thank you, James. It sounded like Bob was also working on an indoor calibration system for his instruments, so maybe some good conversation there.
Hey, Laura, can you hear me?
Yeah, hey, Chris.
Hi. I just thought I'd mention on the Kippen-Zone and IR sensors, they have that sort of flat quartz dome instead of the traditional sort of double thing. And when we purchased them years ago, we were told they didn't require a correction for the dome temperature that the Epleys use. And there's no dome temperature sensor on the one we had. And when we did our observations, we quickly discovered that there was a solar contamination of that sensor. So the sun was heating the dome a little bit, and it was causing a error proportional to the solar flux. I think that's what we saw in that second talk today, when we saw the difference between shaded and unshaded IR flux, which I don't know if that was from a Kippen-Zonen or not. And there's also an issue if it's ventilated or not. So in our case, I believe they were not ventilated, so that might make it worse. It's possible ventilation reduces that effect, but and Kippen-Zonen makes several models of everything. So what I'm saying applies to the model we bought. But I would suggest you're going to need some way of diagnosing solar contamination and correcting it.
Danielle, did you want to respond to that?
Yes, so thank you very much. Yes, I confirm that the peer geometer that were shaded and unshaded are both Kippen-Zonen CGR4, and I guess that and also the unshaded was also unventilated, because that is the configuration that is on the buoy, and probably ventilation may attenuate the dome temperature effect, maybe.
Yeah, so that's relevant to the tau ones. I don't think it's a big deal. I think you can figure it out, and the correction is basically proportional to the solar flux, but needs to be looked at.
Yes, I did this for the apply peer model, the correction for the solar contamination, but did not the same for the Kippenzonen model. Yeah.
So we have about 15 more minutes, and I would love to ask the panelists, based on kind of the work that you've been doing and what you've heard today, where would you recommend that we kind of where would you like to put your energy next? What are the experiments that we need to do, the questions that we need to answer? Be to kind of think about summary of kind of what we've talked about today, or what's been kind of, in your head. Go ahead, Bob.
Well, I thought at one point, Laura, there was some discussion in the community about an intercomparison of the new buoys that James talked about and other buoys like Megan Cronin's OCS buoys and our buoys and maybe other countries' buoys, and maybe setting that up on the beach in Hawaii. And it was part of the funding that NOAA had for reinvesting in Tau. I think maybe you or Tom Farrar or somebody knows more about it, but I'm a real proponent of some intercomparisons. I mean, I don't know, Danielle, whether power and space would allow putting more sensors on Lampedusa. I don't know. I think the Chesapeake Bay Light Tower is gone. I don't know if there's other sites, but I guess I had hoped that this meeting today would kick us off into some intercomparison. I mean, maybe it would even be at a BSRN ground site just to take out some of the variables due to the ocean and to have power available for rapid sampling. I think we have to sample things rapidly and to see the negative effects and understand also the impacts of sampling and algorithms. Back to you.
It's good. Maybe I'll throw that to James. James, is that in the plan, or is there any flexibility in your plan for that kind of testing?
Excuse me. So we're talking about not on a buoy, but on land and high sampling. I mean, we have sensors we could do that with. It's just a matter of where do we want to go with them, right? And I know we've talked to PMEL, talked to Megan about, I think there's a plan. There's a plan to try to do this intercomparison of the entire system, which would include these radiation sensors. We're in the talks now with the groups that are gonna. We haven't gotten together yet to decide how we're going to manage all the groups getting together to do that, but that is still a desire for all of us to get together and see where we are and see, is there an outlier? Is somebody doing it differently that's better, or is somebody doing it differently that's not so good? But being consistent, and also five of us, five organizations getting together, maybe we all can learn something from each other, because I think that's the only way we're going to do this is talking and working some of those issues out. But I'm all for greater sampling. I mean, we have a test, we have a test stand here, but it's just not optimal for what we want to do. We got trees around us and everything else. We really need to be away. It's either that or put it on top of our high bay. That would work too, I guess. we got a very tall building.
Another approach, James, would be for us to have, say, pick one per geometer, and then we'd mail it around to you, to Megan, to whomever, to Danielle, and have each group do the calibration. I mean, in some things, ocean, like salinity measurements, there's a standard seawater that gets sent to each of the labs. I mean, Laura, we could have a standard per geometer and send it to each of the labs and see how the calibrations differ. I know in dealing with EPLI sensors, sometimes we would look at the statistics of the calibrations that EPLI did and see whether the standard deviation of the calibration values made sense compared to the error we thought in the sensor. And sometimes we'd actually say, no, EPLI, that's a bad calibration, and send it back. So I don't know. I mean, we could think of land intercomparisons, we could think of at-sea comparisons, or we could think of a best practice that involved testing each of our calibration capabilities.
Yeah, I mean, I like all of those. I suppose it's a question of who's going to step up to organize, right?
Isn't that you? Isn't that what you're doing?
Is that my job? Is that my job all of a sudden? Look, Megan put a comment in the chat. So Megan says that Ken Connell from PMEL is the point of contact for organizing the intercomparison that James was talking about. Is Ken
That
on?
is a true statement.
Yeah. I don't know. Ken, it looks like you're on. I'm putting you on the spot, but if you're comfortable, would you be willing to speak for a few minutes about how we might work with you on that intercomparison? If you're uncomfortable, that's okay. Hi, Ken.
Hear me?
Yes.
Okay. Yeah. So we are, as James stated, in discussions of this, we still have to formulate a plan and where that funding's coming from and all the details. Yeah, we haven't, made a full decision on, where, when, how, why. Well, the how and the why, yes, but maybe not the where, when, and whatnot. So we're certainly open to input from this community as far as recommendations on certainly locations and also benefits, detriments of doing land-based and for how long versus ocean-based and for how long. And in the past, we have not considered at least we haven't specifically in this context considered the passing around of sensors for running through different calibration procedures, but we could certainly be open to that concept as well. And I tend to agree with Laura that perhaps it's a rather than an either or, perhaps it's an and situation. So anyway, I just wanted to suggest that we're certainly open to input as to best ways to proceed in terms of length of intercomparison, open to locations if because we have not settled on specific locations. So there has been some discussion about Hawaii as a relatively central and good location, but specifically where has not been completely ironed out. And there has been quite a bit of discussion of benefits of land-based versus benefits of ocean-based, and certainly the ocean-based are way more costly, but things can be discovered in whole systems in the environment that we're actually measuring in that cannot be discovered in shorter land-based experiments. So anyway, I'll just leave it at that, and we welcome any input. Thanks.
Thanks, Ken. So an action step that's within my power at the moment, I can certainly send an email to BSRN station scientists and see who would have the capacity and the interest in hosting a land-based comparison. And we can see if there's anybody who has that that kind of bandwidth right now. I can ask around at NOAA. I would, it's not something I could commit to without talking to people in my group, but I think that would be wonderful. And then maybe if Ken and James and Megan keep us updated on kind of as plans continue for the tau buoy intercomparisons, and if you have ocean-based comparisons where other people might be able to jump in, that might be an action step. Bob?
Yeah, years ago we found a site near Woods Hole on the beach where there was a undisturbed fetch for the typical winds, and I think we set up one of our buoys, and we had a PMEL buoy, and we had the Jamstack version of the MET sensors, and we did a beach intercomparison over a summer, and that was very informative. And I was just, in our group thinking about Hawaii, we deploy to Hawaii every year to service the Watts ORS north of Oahu. So, I mean, it's, you could conceivably include in the shipment to Hawaii another set of sensors. And if NOAA could get there and other people could get there, we could start with a beach site with a nice undisturbed fetch. I mean, maybe something on the North Shore could be found so the prevailing trade winds would come in, and we could do a beach intercomparison in Hawaii. I mean, for example.
Yeah, I think it's a great idea.
And you had
Chris
Mauna Loa
again.
then.
There's some things to think about here, because I kind of separate the issue of the sensor calibration and all the other issues that happen to the sensor when you put it out on a buoy or something like that. So really understanding and getting the calibration of the sensor itself, in my opinion, can be done over land, or let's say on the coast. The real issue as far as the tau buoys goes is they're in the tropics, and I think you need to have sun directly overhead as your part of your calibration. So that means Woods Hole and Boulder and PMEL are not good sites to do that, because we never get the sun overhead, I don't think. So that's why Hawaii is attractive, or maybe another island which is closer to the equator. And so I think a land-based calibration is the way to separate the sensor issues. And I'm not sure how important it is that you be on the beach versus a half a mile inland, because you're calibrating the sensor, and the essential thing is you have a BSRN type standard there, maybe two of them, so you're sure you're getting good data. So this calibration needs, it's not so much an inner calibration of a whole bunch of IR sensors, but an absolute calibration. So you need the BSRN sensors too. So it's not a small job.
I would agree with Chris. Sorry,
No, go
did
ahead,
someone
Ken.
else have their hand up? Oh,
Go ahead.
I just wanted to comment. I agree with Chris on both of those points. Firstly, in terms of where ideally we would like to position this intercomparison in the tropics, or if not possible, then subtropics at least. And the second point, in terms of evaluating both the sensors and the systems combined, I completely agree that and just to take that a little further, we are also looking at not just the radiometer sensors, but all the sensors on the moorings. So we're interested in how the individual sensors doing, as well as how are the data transmissions coming through the mooring system, so the data acquisition system, the brain, and is that coloring any of the sensor data? So looking at both of those, the individual sensors as well as the system as a whole, is of great importance. And thank you, Chris, for the comment. I completely agree. Thank you.
We just have one more minute. Megan, you had your hand up. Did you want to speak before we end?
No, actually, Chris said everything I was going to ask about, and suggest that having the standard, the BSRN standard, I think is really would be key to doing this intercomparison, even though it is supposed to be for all the sensors, winds and air temperature and even subsurface sensors. That will be hard to do on land, but the radiation and is, I think, probably one of the hardest parts. So, okay, thanks.
Thanks, Megan. Okay, any last words from our panelists before we close? This has been a fantastic discussion.
Sorry, Lara, I just would address the ventilation issue for the radiometers on the buoy. I guess it may be an advantage if energy is available, and but maybe this could be also an issue because, for example, actual Kippensonen ventilation systems are not small. They occupy space, so you have to have a proper base to host at least 2 ventilation systems, and also you should know how long they can resist in the middle of the sea. But this would certainly improve the measurements, avoiding drop formation and sea salt deposition, and also dust deposition, for example.
I think those are good words to close on. More challenges for us to work on as we move forward. Thank you all so much. This has been wonderful. Once again, I'll put my email in the chat. So if anybody wants to be on our list who isn't, please email me. And thank you so much for joining us this morning or evening or afternoon, whatever time of day it is for you.
Thanks for hosting us and organizing it.